Hi friends, next we see about interference. The phenomenon when the tip of the tooth undercuts the root and its mating gear is known as interference. The minimum number of teeth on pinion in order to avoid interference. So T, small t is the number of teeth on pinion. So capital T, number of teeth on wheel. And M is module of pitch. R is pitch circle radius of pinion. MT by 2. Gear ratio is equal to T by T, that is equal to capital R by small r. So phi pressure angle or angle of mobility. From the given diagram we have to extract the formulas. Limiting radius of pinion addendum circle O1 n is equal to r root of 1 plus capital R by small r into r by r plus 2 sine square pi is equal to mt by 2 root of 1 plus capital T by small t into t by t plus 2 into sine square pi. So from which we can calculate the values. The minimum number of teeth on the pinion, foot system of gear tooth 14 and of composite. Minimum number of teeth on the pinion 12. 14 of full depth involute 32. Then 20 degree full depth involute 18. Then 20 degree stub involute 14. Minimum number of teeth on the wheel in order to avoid interference 2 is equal to 2aw root of 1 plus t by t plus 2 into sine square pi minus 1. We can also written as 2aw, so root of 1 plus 1 by g plus 2 sine square pi minus 1. So next one is the problem number. This is the problem. Determine the number of teeth required on a pinion in order to avoid interference, which is to gear with one egg wheel to give a ratio of 3 to 1 and an equal wheel. The pressure angle is 20 degree and the standard addendum of one module for the wheel may be assumed. Minimum number of teeth per gear ratio 3 is to 1. So the formula is 2 into AW G into root of 1 plus G into 1 plus G plus 2 into sine square pi minus 1, from which we can calculate the value 15.04 or simply we can round off 16. We can take it as maximum value. Minimum number of teeth for equal wheel. Formula is 2 into AW root of 1 plus 3 sine square pi minus 1, from which we can calculate the value 12.34. We can make it as round of 13. Gear trains. So 2 or more gears are made to mesh with each other to transmit power from one shaft to another. Such a combination is called gear train. The train of toothed wheels. These are the gear trains. So types of gear trains can engage: simple gear train, compound gear train, reverted gear train and epicyclic gear train. In first three types gear trains, the axis of the shaft over which gears are mounted are fixed relative to each other. But in case of epicyclic gear trains, the axis of the shaft on which the gears are mounted may be moved relative to fixed axis. Simple gear train. When there is only one gear on each shaft is known as simple gear train. The gears are represented by pitch circles. When the distance between the two shafts small, the two gears 1 and 2 are made to mesh with each other to transmit motion from one shaft to another. Since the gear 1 drives gear 2, therefore gear 1 is called driver and the 2 is called driven or follower. It may be noted that the motion of the driven gear is opposite to the motion of driving gear. Simple gear train. So N1 speed of gear 1, that is for driver. So N2 speed of the gear 2, that is follower. Then T1 number of teeth and the gear 1, that is driver gear. Then number of teeth on the driven gear, that is gear 2. Since the speed ratio or velocity ratio of the gear train is the ratio of the speed of the driver to the speed of the driven or follower. The ratio of speeds of any pair of gears in mesh is the inverse of their number of teeth. Therefore, so speed ratio is equal to N1 by N2 is equal to T2 by T1. It may be noted that ratio of speed of driven or follower to the speed of the driver is known as train value of the gear train. Train value is equal to N2 by N1 divided by is equal to T1 by T2. Simple gear train. Speed ratio, speed of driver divided by speed of driven is equal to number of teeth on driven divided by number of teeth on driver. Train value, speed of driven divided by speed of driver, the number of teeth on driver, number of teeth on driven. So compound gear train, when there are more than one gear on a shaft, is called compound gear of train of gear. Speed ratio for compound gears, speed ratio is equal to speed of first driver, speed of the last driven or follower. The product of number of teeth on the drivens divided by number of teeth on the drivers. Train value is equal to speed of the last driven or follower divided by speed of the first driver. The product of number of teeth on drivers divided by product of number of teeth on the driven. Reverted gear train, when the axis of the first gear, that is first driver, and the last gear, that is last driven or follower, are coaxial, then the gear train is known as reverted gear train. Speed ratio or reverted gear, since the distance between the centers of the shaft of gears 1 and 2 as well as gears 3 and 4 is same. So R1 plus R2 is equal to R3 plus R4. The circular pitch or module of all the gear is assumed to be same. Therefore, teeth on each gear is directly proportional to its circumference or radius. T1 plus T2 is equal to T3 plus T4. Speed ratio is equal to product of number of teeth on drivens divided by product of number of teeth on drivers. So N1 by N4 is equal to T2 into T4 divided by T1 into T3.